Today we are going to prove the following identity with Christoffel symbols. We're told that gamma mu up lambda lambda down is equal to the negative of 1 over 2 times g mu mu down, which is the covariant form of the tensor, times the derivative of g mu mu down with respect to x mu up. The first thing we're going to write are the Christoffel symbols in terms of the metric tensor. Now we see that we want to solve for when nu is equal to lambda. So I'm going to change that variable. I meant to say index instead of variable. We can combine like terms and distribute. That leaves us with 1/2 g alpha mu times g alpha lambda lambda plus 1/2 g alpha mu g alpha lambda lambda minus 1/2 g alpha mu g lambda lambda alpha. Now we can combine like terms. G alpha mu, G alpha lambda, lambda minus 1/2 G alpha mu, G lambda lambda alpha. Now, we want to observe that the metric tensor is diagonal, so the off-diagonal elements are 0. So if we look at the G alpha lambda lambda term, alpha is not equal to lambda, so this term is equal to 0 because it chooses an off-diagonal element. That term is 0. Now we're left with gamma mu lambda lambda is negative 1/2 g alpha mu up times g lambda lambda alpha down. Since the metric is diagonal, the inverse of the metric, or the g alpha mu up term, must have mu mu as its indices. So basically we're just letting alpha equal mu. Alpha. There we go. Now we want to analyze the g mu mu term. And we're going to use the property that g alpha beta times g beta gamma down is equal to delta beta gamma. Alpha gamma. Where beta is contracted. So if we just change all the indices to mu, so we'll have alpha equals mu, beta equals mu, and gamma equals mu. Then we just get delta mu mu, which of course is 1. Now we can solve for g mu mu up, which is just going to be 1 over g mu mu down. And we can just plug this in to our equation. So we'll have gamma mu lambda lambda is negative 1/2 1 over g mu mu down times g lambda lambda alpha. But this is mu because we changed that. Now just putting it in the form that the answer has it in, we'll have negative 2g mu mu to the minus 1. And then this is the partial derivative of g lambda lambda down. And then dx mu up.